Welcome to Lesson 2 in a three-part series on the subject of lean material flow. I'm Richard Rahn. In the previous lesson, we presented three massive mistakes in material flow: not designing delivery routes properly, over-reliance on Kanban, and not having a plan for every part. And if you haven't viewed this lesson yet, you can do so by clicking on the link at the top of this page. In this lesson, we'll dive deeper into one of these three topics: the design of formal delivery routes. But first, let's review why this is important. Now, you already have delivery routes of some sort already. After all, materials need to get to their various points of use one way or another. That's not an option. What we're discussing in detail here is the concept of the water strider, a delivery system that makes frequent deliveries with relatively light loads. Now, here are the main benefits that we discussed in the previous lesson. First, frequent deliveries and light loads means less inventory at the point of use. Inventory reduction may be a goal, but saving physical space and improving operator productivity are equally, if not more, important. A significant hidden waste is the effort that an operator often needs to make, selecting parts and moving to retrieve them. This can represent a big part of each cycle, and also introduces the opportunity for errors. The philosophy of frequent deliveries also has the advantage of adding flexibility in the face of variable usage. If the usage of an item is faster than planned, for whatever reason, having frequent deliveries will help to overcome this. One last thing before we proceed with the design details. Will a formal delivery route system increase your material handling costs? Well, that depends on what you're doing today. But it's also the wrong question. The concern from a company perspective should be on the total cost, including operator efficiency, quality, and space utilization. The total cost to the company should go down. So let's get into designing a delivery route step by step. We're going to need a few items to get started, and by we, I mean you. So first, get yourself a dimensionally correct layout of the delivery area. Don't do it right now, but you'll need that in the future. A CAD drawing of the area with a grid layout, dimensionally correct, will be very helpful to have. Next, you need to create some standards, standard tasks and standard times. So you need to define all of the repeating tasks or work that takes place on a delivery route, and also estimate the time required to complete each task. So here are some of the types of actions that take place, but feel free to add additional ones as needed for your particular environment. Driving a tugger, that's the moving time per yard. Getting onto the vehicle, getting off of the vehicle, delivering containers, picking up empty containers, picking and refilling containers, and so on and so forth. So estimate an average time for each task and do actual time studies, if necessary, to come up with reasonable average estimates. So you now have a decision to make, whether to design your delivery routes as a decoupled system or a coupled system. Now, here are the differences. In a coupled system, the same person will deliver the parts to various points of use and also be responsible for filling empty bins and picking parts. In a decoupled system, the functions of delivering parts and picking parts are done by two separate people. The delivery person will complete a cycle and immediately pick up the next group of containers or the next set of carts. When the delivery cycle is taking place, the second person is preparing the next set of bins and carts. So, which one is better? Well, there's no right answer, but larger facilities tend to operate in the decoupled mode, while smaller plants will use the coupled method. Utilization of equipment with the coupled method will not be as good, since the delivery equipment will be sitting idle while the next load is being picked. On the other hand, it may be possible to respond more quickly with the coupled method, since the filled containers will usually be coming back on the very next cycle. This is not true of the decoupled method. So let's review what we have so far. You have a map of your area, you have standards defined for all of the potential tasks that will need to be done, and you've decided on a coupled-decoupled delivery strategy. So what next? You're almost ready to start experimenting with different delivery routes, but you need to decide on a target cycle time for the delivery route. How many times a day do you want to deliver materials? This is an important decision for a number of reasons. More frequent deliveries will require a higher investment in people and equipment, and you may be used to thinking that material handling is waste that needs to be minimized. Frequent deliveries have a powerful benefit, however, that we've discussed previously. If you have variable usage, and who doesn't, then relatively frequent deliveries provides a safety factor that allows the system to run normally without expediting material and without excessive inventory quantities at the point of use. So here's a rule of thumb. Try to set your delivery route time at about 25% of the average inventory usage time. Now, what do I mean by that? Well, for example, if a bin holds a one-day supply of material, that is, normally it would be consumed in 1 day, then set your delivery route time to 4 times per day. As a point of reference, Toyota Material Handling has set their delivery route time to around 35 minutes. Now, this may seem too frequent, but they rarely run out of material on the line and their inventory turns are excellent. Okay, I think you're now ready to start designing your actual delivery routes. If you're doing this by hand or with a spreadsheet to help with the simple calculations, you'll be trying out different logical routes through the facility in order to maximize your delivery efficiency within the time allowed. So use your spreadsheet to add up the distances and tasks proposed and keep the total route time a bit less than your target delivery route time. Feel free to experiment with alternatives and, if possible, also get on the factory floor and physically walk through the proposed routes. This has been a high-level summary of the steps involved, and you can take it even further, of course. Some companies will build a dynamic simulation model of the proposed routes, which will allow you to add variation to the standard times and give you a better feel for how the route will perform. In most cases, however, you can simply design the route on paper, physically put it in place, and then make adjustments as needed. So this concludes Lesson 2 on the topic of delivery routes, one of the massive mistakes that companies make when they don't design them right. In the next and final lesson, we'll be talking about the creation and use of a plan for every part, your database of everything you need to know about every purchased and manufactured item. So we'll see you then.